The following questions are from the ASA General Oral Study Guide. I will read the questions, provide a short pause for you to formulate your response, and then read the answer. Note: specific question codes referencing the new ACS codes pertaining to the question will appear on the screen. Fundamentals of Electricity and Electronics. 1. What is the difference between the conventional current flow theory and electron flow? Conventional current flow theory is a visualization of current as flowing from positive to negative. In actual practice, electrons in a circuit flow from negative to positive. Parentheses, electron theory. 2. How can you find the polarity of an electromagnet? Hold the electromagnet in your left hand with your fingers encirculating the coil in the direction electrons flow. Parentheses, from negative to positive. Your thumb will point to the north pole of the electromagnet. 3. What constitutes a capacitor? Two conductors separated by an insulator. 4. What is the purpose of a capacitor? It stores electrical energy in electrostatic fields. 5. What is the basic unit of capacitance? The farad. 6. Why should electrolytic capacitors not be used in an AC circuit? They are polarized. An electrolytic capacitor will pass current of one polarity but will block current of the opposite polarity. 7. What is meant by inductance? The ability to store electrical energy in electromagnetic fields. 8. What is the basic unit of inductance? The Henry. 9. Given the inductance and frequency of the AC in a circuit, how do you compute the inductive reactance caused by the coil? X to the subscript L equals 2 pi FL, where X to the subscript L is the inductive reactance in ohms, F equals the frequency in cycles per second, pi is 3.1416, and L is inductance. For example, in an AC series circuit in which the inductance is 146 millihenries and the voltage is 110 volts at a frequency of 60 CPS, the inductive reactance is determined by the following method. X to the subscript of L equals 2 pi times F times L. X to the subscript of L equals 6.28 times 60 times 0.146. X to the L is 55 ohms. That's the inductive reactance. 10. Does the capacitor in an AC circuit cause the current to lead or lag the voltage? It causes the current to lead the voltage. 11. Does an inductor in an AC circuit cause the current to lead or lag the voltage? It causes the current to lag behind the voltage. 12. What is the basic unit of power in a DC circuit? The watt. 13. What happens to the current in a DC circuit if the voltage is increased but the resistance remains the same? It increases. 14. What are the 5 sources of electrical energy? Magnetism, chemical energy, light, heat, and pressure. 15. Which law of electricity is the most important for an aircraft mechanic to know? Ohm's law. 16. What are the elements of Ohm's law? Voltage E, current I, and resistance R. In parentheses, volts, amps, and ohms. 17. What is the name of the law that describes the relationship in an electrical circuit of voltage, current, and resistance? Ohm's law. 18. What is the basic equation of Ohm's law? E equals I times R. 19. What is Kirchhoff's voltage law? Kirchhoff's voltage law states that the algebraic sum of all voltages around a closed path or loop is zero. Another way of saying it is that the sum of all voltage drops equals the total source voltage. 20. What is the formula for determining power? General power formula. P equals I times E, where P equals power, I equals current, and E equals volts. 21. What is Faraday's law? Faraday's law, or the law of electromagnetic induction, states that the induced EMF, or electromagnetic force, in a closed loop of wire is proportional to the rate of change of the magnetic flux through a coil of wire. 22. What is Lenz's law? Lenz's law states that the EMF induced in an electric circuit always acts in such a direction that the current it drives around a closed circuit produces a magnetic field which opposes the change in a magnetic flux. 23. What is the right-hand motor rule? When the index finger of the right hand is pointed in the direction of the magnetic field and the second finger in the direction of current flow, the thumb indicates the direction the current carrying wire moves. 24. What is meant by a kilowatt? 1000 watts. 25. What is meant by a megawatt? 1,000,000 watts. 26. What instrument is used to measure current flow? An ammeter. 27. What is a mega ohm? 1,000,000 ohms. 28. What instrument is used to measure electrical resistance? An ohm meter. 29. When measuring resistance of a component with an ohm meter, should the circuit be energized? No, there should be no power on the circuit. 30. What instrument is used to measure continuity in an electrical circuit? An ohm meter. 31. In what units is battery capacity expressed? In ampere hours. 32. What instrument is used to measure the specific gravity of the electrolyte in a lead-acid battery? A hydrometer. 33. What is voltage? Electrical pressure. 34. What is the basic unit of voltage? The volt. 35. What instrument is used to measure voltage? A voltmeter. 36. To measure voltage, is a voltmeter placed in series or in parallel with the source of voltage? In parallel. 37. What is the voltage across each resistor connected in parallel across a 12-volt battery? 12 volts. 38. What is the open circuit voltage of a lead acid cell? 2.1 volts. 39. How is output voltage regulated in an AC alternator? Voltage regulation is accomplished by varying the strength of the AC exciter fields, parentheses field voltage. 40. What is electrical current? The flow of electrons in a circuit. 41. What is the basic unit of current flow? The ampere, parentheses amp. 42. What part of an amp is a milliamp? 1/1000, in parentheses 0.001 of an amp. 43. What two things happen when current flows through a conductor? Heat is generated and a magnetic field surrounds the conductor. 44. To measure current through a component, is an ammeter placed in parallel or in series with the component? In series. 45. What formula is used to find current when voltage and resistance are known? Current equals voltage divided by resistance. I equals E divided by R. 46. What is meant by resistance in an electric circuit? The opposition to the flow of electrons. 47. What is the basic unit of electrical resistance? The ohm. 48. What four things affect resistance of an electrical conductor? The material, the cross-sectional area, the length, and the temperature. How can you tell the resistance of a composition resistor? By a series of colored bands around one end of the resistor. 50. What formula is used to find resistance when voltage and current are known? Resistance equals voltage divided by current. R equals E divided by I. 51. What is meant by impedance? The total opposition to the flow of alternating current. It is the vector sum of resistance, capacitive reactance, and inductive reactance. 52. In what units is impedance measured? In ohms. 53. How is resistance calculated in a series circuit? For resistors in a series configuration, the total resistance of the circuit is equal to the sum of the individual resistors. 54. How is resistance calculated in a parallel circuit? The formula for the total parallel resistance is as follows. 1 over r to the subscript of t equals 1 over r to the subscript of 1 plus 1 over r to the subscript of 2 plus 1 over r to the subscript of 3 plus 1 over r to the subscript of n. If the reciprocal of both sides is taken, then the general formula for the total parallel resistance is r to the subscript of t equals 1 over r to the subscript of 1 plus 1 over r to the subscript of 2 plus 1 over r to the subscript of 3 plus 1 over r to the subscript of n, where n is the number of total resistors. (55) What is the total resistance of three 12-ohm resistors connected in series? (36 ohms). (56) What is the total resistance of three 12-ohm resistors connected in parallel? 4 ohms. (57) What is the formula for power in a DC circuit? Power equals voltage times current, parentheses P equals E times I. 58. What is the relationship between mechanical and electrical power? 1 horsepower equals 746 watts. 59. What is meant by true power in an AC circuit? The product of the circuit voltage and the current that is in phase with this voltage. 60. In what units is true power expressed? In watts. 61. What is meant by apparent power in an AC circuit? The product of the circuit voltage and the circuit current without reference to phase angle. 62. In what units is apparent power expressed? In volt amps. 63. What is meant by reactive power in an AC circuit? The power consumed in the inductive and capacitive reactance in an AC circuit. Reactive power is also called wattless power. 64. In what units is reactive power expressed? In volt amps reactive, parentheses var, or kilovolt amps reactive, parentheses kvar. 65. What is meant by power factor in an AC circuit? The ratio of true power to apparent power. It is also the ratio of circuit resistance to circuit impedance. 66. How many watts of power are consumed by a 1/5 horsepower 24-volt DC motor that is 75% efficient? Power efficiency is expressed as efficiency equals power out divided by power in. Power consumed is the same as power in, and 1 horsepower equals 746 watts. Therefore, power in equals power out divided by efficiency, equaling 1/5 HP times 746 watts divided by HP divided by 0.75. This simplifies to 0.2 HP times 746 watts per HP divided by 0.75. The answer for power is 199 watts. '67. How much current flows through each of 3 resistors connected in series if the total current is 3 amps? $3 amps. 68. How much current flows through each of 3 equal resistors connected in parallel if the total current is 3 amps? 1 amp. 69. What is meant by the capacity of rating of a lead acid battery? The number of hours a battery can supply a given current flow. 70. What electrolyte is used in a lead acid battery? A mixture of sulfuric acid and water. 71. Does the specific gravity of the electrolyte in a lead acid battery increase or decrease as the battery becomes discharged? It decreases. 72. What is the specific gravity of a fully charged lead acid battery? Between 1.275 and 1.3. 73. How many cells are there in a 24-volt lead acid battery? 12. 74. What is the range of temperatures of the electrolyte in a lead acid battery that does not require a correction when measuring its specific gravity? Between 70 degrees Fahrenheit and 90 degrees Fahrenheit. 75. How do you treat a lead acid battery compartment to protect it from corrosion? Paint it with an asphaltic (tar base) paint or with a polyurethane enamel. 76. What is used to neutralize spilled electrolyte from a lead acid battery? A solution of bicarbonate of soda and water. 77. How high should the electrolyte level be in a properly serviced lead acid battery? Only up to the level of the indicator in the cell. '78. Why is the closed circuit voltage of a lead acid battery lower than its open circuit voltage? Voltage is dropped across the internal resistance of the battery. 79. What gases are released when a lead acid battery is being charged? Hydrogen and oxygen. 80. What is the electrolyte used in a nickel-cadmium battery? Potassium hydroxide and water. 81. Why is a hydrometer not used to measure the state of charge of a nickel-cadmium battery? The electrolyte of a nickel-cadmium battery does not enter into the chemical changes that occur when the battery is charged or discharged. Its specific gravity does not change appreciably. 82. Is the electrolyte level of a nickel-cadmium battery lowest when the battery is fully charged or fully discharged? Fully discharged. 83. What is a result of cell imbalance in a nickel-cadmium battery? The low internal resistance allows current to flow between the unbalanced cells and generate heat. 84. What is a thermal runaway? The large current flow allowed by the low internal resistance causes the cells to produce more heat than they can dissipate. The heat further lowers the internal resistance so more current can flow. This continues until the battery destroys itself. 85. How may thermal runaway be prevented? By carefully monitoring the temperature of the cells and controlling the charging current to prevent an excess of current flow into the battery. 86. How is it possible to know when a nickel-cadmium battery is fully charged? Completely discharge the battery and give it a constant current charge to 140% of its ampere-hour capacity. 87. What is used to neutralize spilled electrolyte from a nickel-cadmium battery? A solution of boric acid and water. 88. What is a transformer and how does it work? A transformer is a device that changes electrical energy into an alternating current of a given voltage into an electrical energy at a different voltage level. It consists of two coils that are not electrically connected but arranged so that the magnetic field surrounding one coil cuts through the other coil. 89. What three things must an electric circuit contain? A source of electrical energy, a load to use the energy, and conductors to join the source and the load. 90. What is meant by continuity in an electrical circuit? The circuit is continuous (parentheses, or complete) when electrons can flow from one terminal of the power source to the other. 91. What is the basic function of a switch? Switches control the current flow in most aircraft electrical circuits. 92. What is a relay? A relay is simply an electromechanical switch where a small amount of current can control a large amount of current. 93. What is the function of a current limiter? A current limiter is a type of heavy-duty fuse, commonly with ratings of 30 amps or greater. They are often used to protect a section of an electrical system, such as a single electrical bus. 94. What materials are fixed resistors made of? The most common fixed resistors are made of a carbon composition. Other types of fixed resistors include carbon film, metal oxide, metal film, and metal glaze. Wire-wound resistors are typically used to control large amounts of current and have high power ratings. 95. What are the two main types of variable resistors? The two main types of variable resistors are the rheostat and the potentiometer. 96. How can you tell the resistance of a composition resistor? By a series of colored bands around one end of the resistor. 97. What happens to the current in a conductor if the length of the conductor is doubled with all other parameters unchanged? The resistance of the conductor would double and current flow would be decreased. 98. Explain the basic concepts of digital logic, including RAM, ROM, NVRAM, logic gates, inverters, rectifiers, and flip-flops. Transistors are used in digital electronics to construct circuits that act as digital logic gates. The purpose and task of a device is achieved by manipulating electrical signals through the logic gates. Thousands and even millions of tiny transistors can be placed on a chip to create the digital logic landscape through which a component's signals are processed. RAM is random access memory that is used for temporary storage in a computer system. ROM stands for read-only memory, and it is a type of non-volatile memory in a computer that is not lost when power to computer is lost. NVRAM stands for non-volatile random access memory, and it is random access memory that is retained even when power is lost. Logic gates provide a set of output signals based on one or more input signals. The input signal is either voltage, parentheses referred to as true, logic 1 or yes, or no voltage, parentheses referred to as false, logic 0 or no. The basic logic gates are and, or, and not. Inverters are used as logic functions, converting a 1 to a 0 or a 0 to a 1. Rectifiers convert AC voltage to DC voltage. Flip-flop, an electrical circuit that can store a single binary signal, either a 1 or 0. The binary state can change based on the input signals. 99. What are binary numbers? The binary number system has only two digits, 0 and 1. It's also known as a base 2 numbering system. 100. What is electrostatic discharge, parentheses, or ESD? Electrostatic discharge is the discharge of static electricity that can build up on a component or a person's body. ESD is a frequent cause of damage to solid-state components and integrated circuits and can be prevented by wearing a grounding wrist strap when handling electrical components. 101. What type of drawing depicts electrical components with respect to each other within a circuit? An electric schematic. 102. What are three types of DC circuits with regard to the placement of the various circuit components? Series, parallel, and series parallel. 103. What are the two general types of AC motors used in an aircraft system? Induction motors and synchronous motors. 104. What is the formula used to determine the speed of an AC motor? RPM equals parentheses 120 times frequency divided by number of poles. 105. In what types of applications is a series wound DC motor most often used? Applications that require high torque and low speed, such as a starter motor. 106. What are the two principal parts of a DC motor? The field assembly and an armature assembly. In this subsection, we are going over risk management questions, noted by the R in the code. So the first question is, when a volt/ohm multimeter is set to measure current, what precautions should be taken? Never place the multimeter leads across a voltage drop, as this can damage the meter. What precautions should be taken in the maintenance shop when both lead acid and nickel cadmium batteries are serviced? The two types of batteries should be kept separate, and the tools used on one type should not be used on the other. 3. What precautions should be taken when working on a high voltage strobe light circuit? Disconnect the power from the strobe power supply and let it stand for 5 to 10 minutes to allow the capacitors to bleed off. 4. What are some of the precautions that should be taken when working around an aircraft battery installed in an aircraft? When disconnecting a battery, always disconnect the negative terminal first. When installing a battery, always connect the negative terminal last. When the battery is installed, care should be taken to never allow tools or equipment to short the positive terminal to ground. Aircraft drawings. How many views can there be on an orthographic projection? 6. How many views are used to show most objects in an aircraft drawing? 3. 3. What information is given in the title block of an aircraft drawing? the name and address of the company who made the part, the name of the part, the scale of the drawing, the name of the draftsman, the name of the engineer approving the part, and the number of the part, parentheses the drawing number. 4. Where is the title block normally located on an aircraft drawing? In the lower right-hand corner of the drawing. 5. How can you know that the aircraft drawing you are using is the most current version of the drawing? By the number in the revision block and by the log of the most recent drawings. 6. What is a detailed drawing? A drawing that includes all the information needed to fabricate the part. What is an assembly drawing? A drawing that shows all the components of a part in an exploded form. A parts list is included with an assembly drawing. 8. What is an installation drawing? A drawing that shows the location of the parts and assemblies on the complete aircraft. 9. What type of drawing is most helpful in troubleshooting a system? A schematic diagram. 10. What is a block diagram? A drawing that shows the various functions of a system by a series of blocks. These blocks do not include any detail, but instead indicate what happens in each block. 11. How are dimensions shown on an aircraft drawing? By numbers shown in the break of a dimension line. 12. What is the purpose of a center line on an aircraft drawing? It divides a part into symmetrical halves. 13. What is the purpose of a sketch of a repair? It shows a specific bit of information and includes the minimum amount of detail needed to manufacture the part. 14. Where would an aviation mechanic find aircraft electrical schematics? In the aircraft maintenance manual or the aircraft wiring diagram manual. 15. What is a fuselage station number? The distance in inches from the datum, measured along the longitudinal axis of the fuselage. 16. What is a butt line? A reference line to the right or left of the center line of the aircraft. Note, this is the risk management section. 1. Why is it important to understand and follow tolerance on aircraft drawings? Tolerance on a drawing controls how parts or components fit together. Incorrectly sized parts could cause damage to the aircraft structure or systems. 2. What is the risk of not following the exact specification for the design of alterations or repairs? Not following the specifications will cause the alteration or repair to be outside of the approved parameters, potentially leading to an unairworthy and unsafe condition. 3. Explain how an aviation mechanic can mitigate applicability risk when using a drawing or schematic. Always confirm that the drawing or schematic applies to the make, model, serial number, and configuration of the aircraft that it is being used for. 4. What risks are associated with not using the most current version of a drawing or not verifying that the drawing applies to the aircraft? Not using the most current revision of a drawing could result in missing important updates. Weight and balance. 1. What is meant by tar weight? The weight of any chocks and other items that are used to hold the aircraft on the scales. 2. What is included in the empty weight of an aircraft? The weight of the airframe, engines, and all items of the operating equipment that have fixed locations and are permanently installed in the aircraft. Empty weight includes optional and special equipment, fixed ballast, full reservoirs of hydraulic fluid and engine lubricating oil, and unusable fuel. 3. What equipment must be installed in an aircraft when it is weighed to find its empty weight center of gravity? All the equipment listed in the aircraft equipment list as required equipment or as equipment that is permanently installed. 4. What is meant by permanent ballast for an aircraft? Weight that is permanently installed in an aircraft to bring the empty weight center of gravity into allowable limits. 5. What is meant by the maximum zero fuel weight of an aircraft? The maximum permissible weight of a loaded aircraft parentheses passengers, crew, cargo, etc., less its fuel. 6. What is meant by undrainable fuel? The fuel that is left in the tank, lines, and components when the aircraft is placed in level flight position and the fuel drained at the main fuel strainer. This is also called residual fuel. 7. What is meant by the datum that is used for weight and balance computation? It is a readily identified reference chosen by the aircraft manufacturer from which all the longitudinal locations on the aircraft are a reference. 8. What is meant by moment in the computation of weight and balance? A force that tends to cause rotation. It is the product of the weight of an object in pounds and the distance of the object from the datum in inches. 9. What is meant by the arm of an item installed in an aircraft? The distance in inches between the center of gravity of the item and the datum. 10. What is meant by a moment index? A moment divided by a constant such as 10, 100, or 1,000. 11. What is meant by the center of gravity range? The distance in inches between the forward allowable center of gravity and the rearward allowable center of gravity. 12. What is a loading envelope? The enclosed area on a graph of an airplane's loaded weight and CG location. If the lines drawn from the weight and CG cross within this envelope, the airplane is properly loaded. 13. What is meant by permanent ballast for an aircraft? Weight that is permanently installed in an aircraft to bring the empty weight center of gravity into allowable limits. 14. When should an aircraft be reweighed? After an extensive repair or alteration that could change its weight or center of gravity. 15. Why is it necessary to consider the category under which an aircraft is licensed when computing its weight and balance? Different categories under which an aircraft can be licensed have different maximum gross weights and different center of gravity ranges. 16. Where do you find the leveling means that are specified for a particular aircraft? In the type certificate data sheets for the aircraft. 17. What must be done with tar weight when an aircraft is weighed? It must be subtracted from the scale readings to find the weight of the aircraft. 18. Why are the distances of all the items installed in an aircraft measured from the datum when computing weight and balance? This makes it possible to find the point about which the aircraft would balance, parentheses, the center of gravity. 19. Where is the maximum allowable gross weight of an aircraft found? In the type certificate data sheets for the aircraft. 20. Is there a federal regulation requiring that all private aircraft be reweighed periodically? No. 21. What must be done to find the empty weight of an aircraft if it has been weighed with fuel in its tanks? The weight of the fuel and its moment must be subtracted from the weight and the moment of the aircraft as it was weighed. 22. How would you find the empty weight and empty weight center of gravity of an airplane if there are no weight and balance records available? The aircraft is weighed and the empty weight center of gravity is computed. These values are recorded in new weight and balance records started for the aircraft. 23. Which has the more critical center of gravity range, an airplane or a helicopter? A helicopter. 24. Where is the center of gravity for most airplanes located in relation to the center of lift? The CG is normally ahead of the center of lift. 25. How do you find the moment of an item installed in an aircraft? Multiply the weight of the item in pounds by its distance from the datum in inches. 26. Where do you find the arm of an item installed in an aircraft? In the type certificate data sheets or the aircraft equipment list. 27. What is the significance of the empty weight center of gravity range of an aircraft? If the empty weight center of gravity falls within the EWC range, the aircraft cannot legally be loaded in such a way that its loaded center of gravity will fall outside of the allowable loaded CG range. Not all aircraft have an EWCG range. 28. What are two reasons weight and balance control are important in an aircraft? For safety of flight and for most efficient operation of the aircraft. 29. What is meant by minimum fuel as is used in the computation of aircraft weight and balance? No more fuel than the quantity necessary for 1/2 hour of operation at rated maximum continuous power. It is the maximum amount of fuel used in weight and balance computation when low fuel may adversely affect the most critical balance conditions. 30. Why is the empty weight center of gravity range not given in the type certificate data sheets for some aircraft? The empty weight center of gravity range is given only for aircraft that cannot be legally loaded in such a way that their loaded center of gravity will fall outside of the allowable limits. 31. Where must a record be kept of the current empty weight and the current center of gravity of an aircraft? In the aircraft flight manual or weight and balance records required by 14 CFR section 23.1583. 32. What must be done with the temporary ballast when weighing an aircraft? It must be removed from the aircraft. 33. Where can you find instructions for jacking the complete aircraft for weighing or to perform a landing gear retraction test? In the aircraft maintenance manual. Note we are in the risk management section. Question 1. Where can you find the instructions for safely jacking an aircraft? In the aircraft maintenance manual. 2. To reduce the risks of an improperly recorded empty weight center of gravity, where would one find the correct procedures for weighing a specific aircraft? In the aircraft maintenance manual. 3. Where can you find the procedures for using scales or load cells for weighing an aircraft? In the aircraft maintenance manual. 4. What are the dangers of the incorrect use of scales when weighing an aircraft? The improper use of scales will cause the recording of incorrect aircraft weights that could cause the aircraft to be loaded outside of safe limits. 5. What is the aerodynamic effect danger of a CG that is either forward or aft of CG limits? The aircraft may become uncontrollable, leading to an accident. 6. What is the effect if an aircraft is loaded in excess of the maximum certified weight? Takeoff and climb performance will decrease and structural limits may be exceeded, all of which could cause an accident. Fluid lines and fittings. 1. Of what material are most low-pressure rigid fluid lines made? (1100-1/2 hard or 3003-1/2 hard aluminum alloy tubing). 2. Is the size of a rigid fluid line determined by its inside or its outside diameter? By its outside diameter. 3. What is the difference between the flare angle for aircraft and automotive fittings? Aircraft fittings have a 37-degree flare angle and automotive fittings use 45 degrees. 4. Where are quick disconnect fluid line couplings normally used in an aircraft hydraulic system? In the lines that connect the engine-driven pump into the hydraulic system. 5. Is the size of a flexible hose determined by its inside or its outside diameter? By its inside diameter. 6. Of what pressure should rigid fluid lines be made that carry high pressure (3000 psi or greater) hydraulic fluid? Annealed, or 1/4 hard corrosion-resistant steel. 7. What is the principal advantage of Teflon hose for use in an aircraft hydraulic system? Teflon hose retains its high strength under conditions of high temperature. 8. How tight should an MS flare fitting be tightened? Tighten the fitting by hand until it's snug. Then turn it with a wrench for 1/6 turn to 1/3 turn. Never turn it more than 1/3 turn with a wrench. 9. What damage can be caused by over-tightening an MS flare fitting? Over-tightening drives the cutting edge of the sleeve deep into the tube and weakens it. 10. What kind of ridge tubing can be flared with a double flare? (5052-0) and 6061-T aluminum alloy tubing in sizes from 1/8 inch to 3/8 inch OD. 11. What should be done to the end of a tube that is to be flared? The cut end should be polished to remove any sharp edges that could cause the tubing to crack. 12. What is the minimum amount of slack that must be left when a flexible hose is installed in an aircraft hydraulic system? The hose should be at least 5% longer than the distance between the fittings. This extra length provides the needed slack. 13. How much pressure is used to proof test a flexible hose assembly? This varies with the hose, but it is generally about 2 times the recommended operating pressure for the hose. 14. Why is it important to use a torque wrench when securing fluid hose and line fittings? If the connection is too loose, it may leak. If the connection is too tight, it can cause the fitting to become damaged and fail. 15. What is the purpose of using torque seal on a critical fitting after installation? If a visual inspection reveals that the torque seal has broken, it is an indication that the fitting may have loosened. Note we are in the risk management section. 1. Why is it important to understand system configurations during aircraft maintenance? A lack of understanding of a system could lead to fluid lines being reversed or incorrectly installed, leading to potentially hazardous situation. 2. What safety equipment should be considered when working on fluid lines? Depending on the types of fluid, safety equipment may include gloves and clothing protection, eye protection, spill containment materials, respirator, and fire extinguisher. 3. How can an aviation mechanic determine what fluids are contained in the hoses and fluid lines that are encountered when working on an aircraft? Fluid lines and hoses are labeled at regular intervals to identify the type of fluid. Additionally, the aircraft maintenance manual provides information on each aircraft system. 4. What risk mitigation action should occur prior to working on any pressurized fluid system? The system must be depressurized prior to beginning any work on the system. 5. What is the function of the ley line? Parentheses, the identification strip that runs the length of a flexible hose. To show the mechanic whether or not the line was twisted when it was installed. The line should be straight, not spiraled. A twisted hose may move from its intended position and chafe or interfere with other systems. 6. What is the danger of a loosened fitting or a hose that has moved out of position? A loosened fitting may leak or allow a hose to move out of position. A hose that has moved out of position may chafe on adjacent structures and begin to leak, or may cause interference and damage to other systems. 7. What precaution must be used when applying torque to a fluid line? The fitting that the line is being torqued to must be held in position with a second wrench to prevent twisting or damage to the secondary fitting or line. Aircraft materials, hardware, and processes. 1. What is the alloy number of the most commonly used aluminum alloy for aircraft structural use? 2024-T. 2. What is the alloy number of a high-strength aluminum alloy that has zinc as an alloying component? 7075. 3. What type of composite material is used when stiffness is the prime requirement? Graphite, parentheses, carbon. 4. What type of composite material is used when toughness is the prime requirement? Kevlar. 5. Why is a piece of steel tempered after it has been hardened? When steel is hardened, it becomes brittle. Tempering removes some of this brittleness. 6. How is steel annealed? It is heated to just above its upper critical temperature until it reaches a uniform temperature throughout, then it is allowed to cool very slowly in the oven. 7. How is steel hardened? It is heated to its critical temperature and quenched in water, brine, or oil. 8. What is meant by tempering steel? The steel is first hardened, then some of the hardness is removed to relieve some of the internal stresses and brittleness. 9. What is meant by case hardening? The surface of the metal is hardened by the infusion of carbon or aluminum nitride. The interior of the metal remains strong and tough. 10. What are two methods of case hardening? Carburizing and nitriding. 11. How is steel nitrided? The steel part is heated in a retort in which there is an atmosphere of ammonia, parentheses, a compound of nitrogen and hydrogen. Aluminum, an alloying element in the steel, combines with the nitrogen to form an extremely hard aluminum nitride on the surface of the steel. 12. What is the method of solution heat treatment of an aluminum alloy? The metal is hardened by heating it in a furnace to a specified temperature and immediately quenching it in water. It is soft when it is removed from the quench, but as it ages, it regains its hardness. 13. What is the method of precipitation heat treating an aluminum alloy? The metal is heated and quenched, then it is returned to the oven and heated to a lower temperature. It is held at this temperature for a specified time, then removed from the oven and allowed to cool in still air. This increases the strength and hardness of the metal. Precipitation heat treating is also called artificial aging. 14. What is another name for precipitation heat treatment? Artificial aging. 15. Identify and explain the differences between heat-treated and non-heat-treated aluminum alloys. Heat-treated aluminum alloy designations are normally followed with a -T, followed by a number between 1 through 10 that designates the type of heat treatment. A common aircraft aluminum alloy is 2024-T3. Heat-treated aluminum alloy is stronger than non-heat-treated aluminum alloy. 16. Why is it important that a piece of aluminum alloy be quenched immediately after it is removed from the heat-treating oven? Any delay in quenching aluminum alloy after it is removed from the oven will allow the grain structure to grow enough that intergranular corrosion is likely to form in the metal. 17. Describe and explain the forces placed on aircraft materials. Tension, a force tending to stretch or elongate the material. Compression, a force tending to compress or shrink. Torsion, a twisting force on an object. Bending, a perpendicular force on the longitudinal axis of an object, causing it to flex or bend. The inner surface of the bend will be in compression and the outer surface of the bend will be in tension. Strain, the stress on an object which can cause the object to change shape or to become distorted. Shear, a force that tries to cut or slice through an object. The force is parallel to the material cross-section. 18. What type of loading should be avoided when using a self-locking nut on an aircraft bolt? A self-locking nut should not be used for any application where there are any rotational forces applied to the nut or to the bolt. 19. What determined the correct grip length of a bolt used in an aircraft structure? The grip length of the bolt should be the same as the combined thickness of the materials being held by the bolt. How tight should the nut be installed on a clevis bolt that is used to attach a cable fitting to a controlled surface horn? The nut on a clevis bolt should not be tight enough to prevent the clevis bolt from turning in the cable fitting and the horn. 21. What bolt is described by this number? AN6-14A. AN6 equals hex head bolt, 6/16 or 3/8 of an inch diameter. 14 stands for the length and is 1 1/2 inch long. A equals the shank that is not drilled for a cotter bank. 22. What is indicated by a triangle on the head of a steel bolt? This is a close tolerance bolt. 23. What is a correct application for self-tapping sheet metal screws on an aircraft? They may be used to hold non-structural components onto the aircraft. 24. How can you tell when a self-locking nut must be discarded? When you can screw the nut onto a bolt without having to use a wrench. 25. What is a channel nut? A series of nuts mounted loosely in a channel that is riveted to the aircraft structure. You can install screws in a channel nut without having to hold the nut with a wrench. 26. Of what two materials are cotter pins made? Low carbon steel and corrosion resistant steel. 27. What is the smallest size cable that is allowed to be used in the primary control system of an aircraft? One-eighth inch diameter. 28. What type of control cable must be used when pulleys are used to change the direction of cable travel? Extra flexible cable, parentheses 7 times 19. 29. What is the purpose of safety wire? To prevent a nut, bolt, or other component from loosening. 30. After torquing a castellated nut, can the nut be loosened to align with the hole in a bolt for installing the cotter pin? No. Never over-torque or loosen a torque nut to align safety wire or cotter pin holes. The nuts should be torqued to the minimum torque and then tightened to align with the safety hole without exceeding the maximum torque. 31. What kind of measuring instrument is used to measure the run out of an aircraft engine crankshaft? A dial indicator. 32. What measuring instruments are used to measure the fit between a rocker arm shaft and its bushing? The outside diameter of the shaft is measured with a micrometer caliper. The inside of the bushing is measured with a telescoping gauge and the same micrometer caliper. 33. In what increments can a vernier micrometer caliper be read? 1/10,000, parentheses 0.0001 inch. 34. What is an advantage of a vernier caliper over a micrometer caliper? The range of a vernier caliper is far greater than that of a micrometer caliper. 35. What precision tool is used to measure piston ring side clearance? Thickness gauge. 36. What precision tools are used to measure the inside diameter of a cylinder? A telescoping gauge and a micrometer caliper. 37. What precision tools are used to measure the inside diameter of a small hole? A small hole gauge and a micrometer caliper. 38. What kind of solder is recommended for soldering electrical wires? (60/40) resin core solder. 39. What is the function of the flux used in soldering? Flux covers the cleaned and heated metal to keep oxygen away from it so oxides cannot form. Oxides keep the solder from adhering to the surface of the metal. 40. What are the three most common types of torque wrenches? Deflecting beam, dial indicating, and micrometer setting types. 41. Where would an aviation mechanic find the appropriate hardware specifications for use on a particular aircraft? In the Aircraft Manufacturer Illustrated Parts Catalog, otherwise known as IPC. 42. Where would an aviation mechanic find the material specification for structural repairs on an aircraft? In the Aircraft Manufacturer Structural Repair Manual, otherwise known as SRM. 43. Why is it very important that the surface of a piece of clad aluminum alloy not be scratched? The pure aluminum used for cladding is non-corrosive, but the aluminum alloy below the cladding is susceptible to corrosion. If the cladding is scratched through, corrosion could form. 44. What is the preload value when torquing a nut? Preload is the force or torque required to overcome the friction between the threads on the nut and the threads of the bolt prior to the nut contacting the mating surface. 45. How is the preload value used when torquing a nut? The preload torque is added to the specified torque to obtain the required setting on the torque wrench. 46. How can the material of a bolt be identified? By manufacturer markings that are on the bolt head. 47. How is the welding flux removed from a piece of aluminum that has been gas welded? It should be removed by scrubbing it with hot water and a bristle brush. 48. What are the visual characteristics of a good weld? A good weld is uniform in width, the ripples are even and well feathered into the base metal, and show no burn due to overheating. The weld has good penetration and is free of gas pockets, porosity, or inclusions. 49. What are the visual characteristics of a bad weld? A bad weld has irregular edges and considerable variation in the depth of penetration. It often has the appearance of a cold weld. 50. What must be done to a welded joint if it must be re-welded? All traces of the old weld must be removed so the new weld will penetrate the base metal. 51. What is meant by normalizing a piece of steel after it has been welded or machined? Normalizing removes stresses that are locked into the material by welding or machining. 52. How is a steel structure normalized after it has been welded? Heat the steel structure to a temperature above its critical temperature and allow it to cool in still air. 53. What determines the size of tip that is to be used when gas welding steel? The thickness of the material being welded, the size of the tip orifice determines the amount of flame produced and thus the amount of heat put into the metal. Note we are in the risk management section now. Question 1. What are the common personal protection equipment (PPE) items that an aviation mechanic should have access to? Hearing protection, eye protection, gloves, aprons, dust masks, and respirators. 2. What are some of the dangers that could be caused by improper torque? Too low of torque can cause components to loosen and come apart. Too high of torque could cause failure of the bolt or component or cause a rotating component to seize and non-function as designed. All of these failures could cause loss of a system or even loss of an aircraft and potential loss of life. 3. Why is the use of used hardware or suspected unapproved parts, otherwise known as SUPS, undesirable? In addition to creating an unairworthy condition, the risk of failure increases, which could cause damage to a system or the aircraft. 4. Where would an aviation mechanic find the proper procedure for torquing critical highly stressed fasteners? In the aircraft manufacturer's maintenance manual. 5. What is the proper technique when using a torque wrench? Pull the wrench assembly with a smooth, steady motion until the proper torque is reached. A fast or jerky motion will result in an improper torque. Ground operations and servicing. 1. What special precautions should be taken when towing an aircraft that is equipped with a steerable nose wheel? Be sure that the nose wheel does not try to turn past its stops. Some aircraft require the torsion links on the nose wheel strut to be disconnected when towing. 2. What kind of rope is best to tie down an aircraft? Nylon or polypropylene? 3. What kind of knot is used for securing an airplane with a rope? Bowline. 4. What are the correct procedures to use when pressure fueling an aircraft? Most pressure fueling systems consist of a pressure fueling hose and a panel of controls and gauges that permit one person to fuel or defuel any or all fuel tanks of an aircraft. Each tank can be filled to a predetermined level. Always ensure that a ground is established between the fueling equipment and the aircraft prior to fueling. Prior to fueling, the person fueling must check the following. Ensure all aircraft electrical systems and electronic devices, including radar, are turned off. Do not carry anything in shirt pockets. These items could fall into the fuel tanks. Ensure no flame-producing devices are carried by anyone engaged in the fueling operation. A moment of carelessness could cause an accident. Ensure that the proper type and grade of fuel is used. Do not mix AV gas and jet fuel. Ensure that all the sumps have been drained. Wear eye protection. Although generally not as critical as eye protection, other forms of protection such as rubber gloves and aprons can protect the skin from the effects of spilled or splashed fuel. Do not fuel aircraft if there is danger of other aircraft in the vicinity blowing dirt in the direction of the aircraft being fueled. Blown dirt, dust, or other contaminants can enter an open fuel tank, containing the entire contents of the tank. Do not fuel an aircraft when there is lightning within 5 miles. Do not fuel an aircraft within 500 feet of operating ground radar. 5. What are the most common aviation gasoline colors and corresponding grades? Red 80, green 100, blue 100 LL, purple 115. 6. What publications list the standard hand signals used for directing a taxiing aircraft? FAA Aeronautical Information Manual and Aviation Maintenance Technician Handbook, General, parentheses FAA-H-8083-30. 7. What action should a mechanic take while taxiing an aircraft on a runway if the tower shines a flashing red light at him? Taxi the aircraft clear of the runway in use. 8. When starting an aircraft engine equipped with a float carburetor, in what position should the carburetor heat control be placed? In the cold position. 9. What is meant by a liquid lock in the cylinder of an aircraft engine, and how is it cleared? Oil accumulates in the cylinders below the center line of the engine and prevents the pistons from moving to the top of its stroke. To clear a liquid lock, remove one of the spark plugs and turn the engine crankshaft until all of the oil is forced out of the cylinder. 10. What is the procedure if a hung start occurs when starting a turbojet engine? Terminate the starting operation and find the reason the engine will not accelerate as it should. 11. How far ahead of an idling turbojet engine does the danger area extend? 25 feet. 12. What are the control tower light signals that may be used when taxiing or towing an aircraft, and what are their meanings? Flashing green means cleared to taxi. Steady red means stop. Flashing red means taxi clear of runway in use. Flashing white means return to starting point. Alternating red and green means exercise extreme caution. 13. What is meant by denotation in an aircraft reciprocating engine? Detonation is an uncontrolled burning of the fuel in the cylinder of an engine. It is an explosion rather than a smooth burning. 14. What type of fire extinguisher is best suited for extinguishing an induction fire in a reciprocating engine? Carbon dioxide, otherwise known as CO2. 15. What is proper way to extinguish an induction system fire that occurs when starting a reciprocating engine? Keep the engine running, which will blow the fire out. If this does not work, use a CO2 fire extinguisher directed into the induction air inlet. 16. When servicing an aircraft with air, nitrogen, oil, and other fluids, what are the proper procedures and equipment requirements found? Consult the specific aircraft maintenance manual. 17. What are the 3 types of oxygens that are commercially available? Aviators breathing, industrial, and medical. 18. Is medical oxygen a suitable alternative for aviators breathing oxygen? No. Medical oxygen contains moisture that can freeze in the cold temperatures found at higher altitudes. 19. What grade of aviation gasoline is dyed blue? Low lead grade 100. 20. What type of fuel is Jet A? A fuel with a heavy kerosene base, a flash point of 110 to 150 degrees Fahrenheit, a freezing point of -40 degrees Fahrenheit, and a heat energy content of 18,600 BTU per pound. 21. What are 2 functions of tethyl lead that is added to aviation gasoline? It increases the critical pressure and temperature of the fuel, and it acts as a lubricant for the valves. 22. Why is it important that turbine fuel not be mixed with aviation gasoline used in an aircraft reciprocating engine? The turbine engine fuel will cause the engine to detonate severely. 23. What is the danger of using fuel that vaporizes too readily? Vapor lock can occur in the fuel lines. This will shut off the flow of fuel to the engine. 24. How can an aviation mechanic reduce the risk of leaving tools in an aircraft? By using shadow boards or foam cutouts for each tool in their toolbox. Missing tools are easily identified by a quick review of the toolbox. 25. Why is it important that the aircraft and the fuel truck be grounded together before the aircraft is fueled? Grounding prevents the buildup of static electricity that causes sparks that could ignite the fuel vapors. 26. How should aircraft parts be protected? When stored on a shelf, sensitive equipment should remain in original packing or on padded shelves with measures taken to prevent parts from rolling or falling off storage shelves. Electronic equipment should remain in anti-static packaging. When moving aircraft parts to be installed on an aircraft, care should be taken to prevent the part from falling or becoming damaged until installation is complete. 27. Where can information be found specifying what personal protective equipment, PPE, should be used when working with specific hazardous materials? In the safety data sheet for the hazardous material. 28. Why is FOD, foreign object damage, dangerous? FOD can lead to damage and failure of aircraft systems and engines. Note we are in the risk management section. Question 1. Explain the precautions that should be used when towing an aircraft. Before the aircraft to be towed is moved, a qualified person must be in the flight deck to operate the brakes if the tow bar breaks or becomes unhooked. Use the proper tow bar. Observe tow steering limits and disconnect steering linkages when appropriate. Tow at reasonable speeds. Use wing walkers to verify wingtip clearance from obstacles. Close external doors and air stairs. Install geared down lock pins when available. Follow airport control tower or ground control instructions and clearances. 2. What precautions should be used when connecting external power equipment to an airplane? Consult the aircraft manufacturer's recommendations. In most cases, 1. Turn aircraft power. 2. Turn external power equipment off and ensure proper voltage has been selected. 3. Connect external power to the aircraft. 4. Turn external power on. And 5. Turn aircraft power on. 3. What documentation is required for a certified aircraft to legally operate on automotive gasoline? There must be a supplemental type certificate for the aircraft to operate on automotive gasoline. 4. What hazard is associated with fueling or defueling ungrounded aircraft? Aviation fuel vapors exist when fueling or defueling an aircraft. During the process of fueling or defueling an aircraft, static electricity builds up due to the flow of fuel inside a rubber fueling hose, and if not grounded properly, can cause a spark that ignites the fuel vapors. 5. What should be done to a reciprocating engine fuel system if turbine fuel is inadvertently put into the tank and the engine is run? The entire fuel system must be drained and flushed with gasoline, the engine given a compression check, and all the cylinders given a borescope inspection. The oil must be drained and all of the filters and strainers checked. After the aircraft is properly fueled, the engine must be given a proper run-up and check. 6. What damage is likely to occur if an aircraft reciprocating engine that is designed to use grade 100 fuel is operated with grade 80 fuel? Detonation will occur, leading to bent connecting rods, burned pistons, and cracked cylinder heads. 7. What information must be located near the fuel tank filler opening in an aircraft powered by a reciprocating engine? The word avgas, the minimum fuel grade. 8. What information must be located near the fuel tank filler opening in an aircraft powered by a turbine engine? The words jet fuel, the permissible fuel designations, or references to the airplane flight manual, AFM. For permissible fuel designations. Additionally, for pressure fueling systems, the maximum permissible fueling supply pressure and the maximum permissible defueling pressure. 9. What precaution must be observed regarding the tools used when servicing an aircraft oxygen system? Be sure that there is no oil or grease on the tools. Pure oxygen can cause spontaneous combustion of petroleum products. Two personnel should be used, one for controlling the valves of the servicing equipment and the other to monitor the pressure in the aircraft system. Do not service the oxygen system when fueling, defueling, or conducting any maintenance that could provide a source of ignition. 10. Why is it important to use a checklist when starting and running an aircraft engine? Using a checklist will lead to safe conditions, protecting the aircraft, surrounding equipment, and personnel. 11. Where are the procedures found to start an aircraft engine correctly and safely? In the specific aircraft manufacturer's aircraft maintenance manual or aircraft flight manual. 12. Explain how to mitigate risk when starting and operating an engine while troubleshooting or adjusting engine controls. Always follow the specific aircraft maintenance manual instruction and cautions. Adjustments to the engine should be made only when the engine is not running. 13. What are the dangers of operating an aircraft engine with cowling removed contrary to manufacturer's instructions? The aircraft cowling may become damaged, the engine may not receive enough cooling air and overheat, and or damaged cowling may come loose and damage the engine, propeller, or aircraft. 14. What are some of the risks associated with operating an aircraft in the vicinity of other aircraft or ground support equipment, and how can the risks be mitigated? Always aim an aircraft so that the blast from the propellers or engines will not damage other aircraft, equipment, or personnel. Cleaning and corrosion control. 1. What is used to clean transparent plastic windshields and windows of an aircraft? Mild soap and lots of clean water. 2. What is used to neutralize the electrolyte from a lead-acid battery that has been spilled on an aircraft structure? A solution of bicarbonate of soda and water. 3. What is used to neutralize the electrolyte from a nickel-cadmium battery that has been spilled on an aircraft structure? A solution of boric acid and water or vinegar. 4. What solvent is recommended for removing grease from aircraft fabric prior to doping it? Methyl ethyl ketone (MEK) or lacquer thinner. 5. What is the proper way to clean plastics? Flush the plastic with clean water. Remove dirt by hand. Plastics are easily scratched and usage of racks is not recommended. 6. What causes corrosion? Corrosion is a natural phenomenon that attacks metal by chemical or electrochemical action and converts it into a metallic compound, such as oxide, hydroxide, or sulfate. Corrosion occurs because of the tendency for metals to return to their natural state. Noble metals like gold and platinum do not corrode since they are chemically uncombined in their natural state. Conditions that can cause corrosion to develop or worsen are moisture, act as an electrolyte, oxygen, acts as a catalyst, chemicals, initiate or catalyze the electromechanical process, and temperature, accelerate the process. 7. Where is fill-form corrosion most likely to occur on an aircraft? Under a dense coating of top-coat enamels such as polyurethane. Fill-form corrosion is caused by improperly cured primer. 8. Where is fretting corrosion most likely to occur on an aircraft? In a location where there is a slight amount of relative movement between two components and no way for the corrosive residue to be removed as it forms. 9. Where is intergranular corrosion most likely to occur on an aircraft? Along the grain boundaries of aluminum alloys that have been improperly heat treated. Extruded aluminum alloy is susceptible to intergranular corrosion. 10. Where is stress corrosion most likely to occur on an aircraft? In any metal component that is continually under a tensile stress. The metal around holes and castings fitted with pressed-in bushings is susceptible to stress corrosion. 11. What areas of an aircraft are most prone to corrosion? Battery compartment, exhaust system and exhaust trails, wheel wells, lower area of the belly, which is known as the bilge, piano hinges, area of dissimilar metal contact, welded areas, inside of fuel tanks, especially integral fuel tanks, metal fittings under high stress, lavatories and food service areas. 12. What is used to keep a corrosion from forming on structural aluminum alloy? An oxide coating or aluminum cladding. 13. How should an A&P minimize corrosion at piano hinges? Piano hinges should be kept as clean and dry as practical and lubricated with a low viscosity moisture dispersing agent. 14. How is the inside of structural steel tubing protected from corrosion? The tubing is filled with hot linseed oil and then drained. 15. How does film corrosion usually appear on an aircraft structure? As thread-like lines of puffiness under a film of polyurethane or other dense finish system topcoats. 16. What must be done to a piece of aluminum alloy to remove surface corrosion and to treat the metal to prevent further corrosion? Remove the corrosion residue with a bristle brush or a nylon scrubber. Neutralize the surface with a chromic acid or with some type of conversion coating. Protect the surface from further corrosion with a coat of paint. 17. How may rust be removed from a highly stressed metal part? By glass bead blasting, by careful polishing with mild abrasive paper, or by using fine buffing compound on a cloth buffing wheel. 18. What tools are proper for removing corrosion from aluminum alloy? Aluminum wool or aluminum wire brushes. Severe corrosion can be removed with a rotary file. 19. What type of device is used to remove surface corrosion from a piece of magnesium alloy? A stiff hog bristle brush. 20. What must be done to a piece of aluminum alloy to remove surface corrosion and to treat the metal to prevent further corrosion? Remove the corrosion residue with a bristle brush or a nylon scrubber. Neutralize the surface with a chromic acid or with some type of corrosion coating. Protect the surface from further corrosion with a coat of paint. 21. How is rust removed from a highly stressed metal part? By glass bead blasting, by carefully polishing with mild abrasive paper, or by using fine buffing compound on a cloth buffing wheel. 22. What is a corrosion preventative compound, CPC? CPC is a waxy sealant or a thin film dielectric that can be sprayed into aircraft structures to coat the surface and work its way between the skins to prevent corrosion. 23. What type of environment would CPCs normally be used in? CPCs are used in corrosive environments such as aerial agriculture spray operations and saltwater environments. 24. How are CPCs applied to aircraft structures? CPCs are normally applied with high-pressure spray equipment that creates a fog of the CPC material inside the aircraft structure. Long spray wands are used to reach difficult-to-access areas. 25. What is used to clean a composite material prior to repair? Acetone or methyl ethyl ketone (MEK) is commonly used. It is important to verify that the solvent residue is compatible with the resin system. 26. Where is dissimilar metal corrosion most likely to occur on an aircraft? Anywhere different types of metals come in contact with each other, especially where moisture is present. 27. What can be used to repair the anodized surface of an aluminum alloy part? A chemical conversion coating such as iodine. 28. What are the three types of primers that may be used when painting an aircraft? Zinc chromate primer, wash primer, and epoxy primer. 29. What type of thinner is used with zinc chromate primer? Toluol or toluene. 30. What type of primer is used when the maximum protection of the metal is required? Epoxy primer. 31. What are some different types of primer materials? Wash primers, red iron oxide, gray enamel undercoat, urethane, epoxy zinc chromate. 32. How thick should a coat of wash primer be that is used on an aluminum alloy aircraft structure? It should be thin enough that it does not hide the surface of the metal. 33. What are some different types of top coat materials? Dope, synthetic enamel, lacquers, polyurethane, urethane, acrylic urethane. 34. What is the primary purpose of a finish on a composite material? To protect the composite structure from ultraviolet degradation. 35. What are the methods used to remove finishes from a composite material? By light sanding or abrasive blast with plastic media. 36. When mixing epoxy paint, should the converter be added to the resin or the resin to the converter? The converter should always be added to the resin, never the resin to the converter. 37. What should be done to a corroded aluminum alloy surface after the corrosion has been removed by mechanical methods? The surface should be treated with a chemical conversion coating before the top coats are applied. (38) What may be done to the surface to prevent fillform corrosion beneath the top coat? Be sure that the primer is properly and completely cured. 39. How is the finish removed from a fiberglass aircraft component that is being repaired? The finish must be sanded off. Paint remover can soften to the resin of which the component is made. 40. How can a vinyl film decal be removed from an aluminum alloy surface? Place a cloth saturated with glycol oxen or MEK over the decal until it is softened and scrape it off of the surface with a plastic scraper. 41. Why is retarder used in dope when the dope is being sprayed in humid conditions? The retarder slows the drying of the dope and keeps it from blushing. 42. What is meant by dope blushing and what causes it? Blushing is a condition in a dope finished component in which moisture from the atmosphere condenses on the surface and causes some of the cellulose to participate from the finish. Blushing leaves a porous, dull, and weak finish. Blushing may be caused by the temperature being too low, the humidity being too high, or by drafts or sudden changes in the temperature. 43. What causes blushing in a dope finish? Too high humidity. 44. What causes fish eyes in the finish? Localized surface contamination. 45. Where are the registration marks required to be placed on a fixed-wing aircraft? On a vertical tail surface or on the side of the fuselage. 46. What is the generally required dimensions of the registration numbers on the side of a fixed-wing aircraft? 12 inches tall and 2/3 as wide as they are high. The letters M and W may be as wide as they are high. The numeral 1 is 1/6 as wide as it is high. 47. What is the regulation regarding the color of the registration marks? The color must contrast with the background and be legible. 48. What is the cause of poor adhesion between the top coat and the fill coats on a fabric surface? Too much aluminum powder in the aluminum pigmented dope. 49. What is the cause of a rough finish on a freshly sprayed surface? Too high atomizing air pressure on the spray gun. 50. What causes sags and runs on a surface that has just been sprayed? Too much finishing material being applied in one coat. 51. What causes orange peel or a spray model in a finish? Incorrect paint viscosity or improper setting of the spray gun. 52. What causes pinholes in a finish? Excessive atomizing air on the spray gun. 53. What safety precaution must be observed when sweeping a paint room that has dry dope or lacquer overspray on the floor? The floor must be wet down with water before it is swept. Static electricity from dry sweeping can cause a fire. 54. What personal protection equipment, PPE, should be used while painting? Respirator, eye protection, and skin protection. 55. Why are some portions of the structure of an aircraft dope-proofed before they are covered with fabric? Dope proofing keeps the fabric from sticking to the structure when the first coat of dope is applied. The fabric normally sags enough to touch the structure before it begins to pull taut. 56. What are some key application techniques for a quality paint job? Correct spray pressures and spray gun setting, proper spray gun handling, parentheses, even, overlapping spray patterns, spray gun distance, and good lighting. 57. Why should control surfaces be balanced after painting? The weight or distribution of the paint may have changed and the control surface may be out of tolerance. Note we are in the risk management section. Question 1. Explain the health concerns that need to be addressed when using paint, solvents, and finishing materials. Hazardous materials may cause short-term or long-term damage to an individual. Always use appropriate PPE. 2. Describe the risks associated with poor ventilation when painting. Poor ventilation will cause higher concentrations of vapors, such as which can be very volatile. High concentrations of paint in the air will also lead to overspray on the aircraft, leading to a poor quality paint job. 3. What risks or hazards are present if material or processes for corrosion, cleaning, and treatment are not followed correctly? Some chemicals used for cleaning metal or stripping paint can cause damage to undamaged paint, systems, or aircraft windows. The application of a top coat over an area where the corrosion has not been fully removed may trap corrosion or moisture, leading to further corrosion. The incorrect method of removing corrosion may cause severe damage to a part or structural assembly. 4. Why is it important to have access to the SDS safety data sheet for the products used during removal and treatment of corrosion? The SDS provides specific guidance on what PPE should be used, parentheses such as gloves, eye protection, respirators, etc., when working through the corrosion removal and treatment process. 5. Explain the precautions that should be taken when working with flammable chemicals. Always follow the guidelines found in the SDS. Use proper containers, ventilation, and PPE, and have the correctly rated fire extinguisher on hand. Store or dispose of cleaning rags in appropriately rated fireproof containers. 6. Describe the proper disposal of chemicals and waste materials. Chemicals and waste materials must be disposed of in accordance with the Environmental Protection Agency, EPA, regulations and local laws and ordinances. 7. What are the dangers of not using the proper PPE when working with paints and solvents? Paints and solvents can cause both short-term and long-term damage to an individual's health, up to and including death. 8. Explain how to mitigate the risks and hazards associated with the application of finishing materials. Always use an appropriately rated painting booth that filters and contains vapors and solvent. Use the correct PPE, which often includes a full painting suit with gloves, eye protection, and a respirator. Mathematics. 1. What formula is used to find the area of a circle? Area equals pi over 4 times diameter squared. Or area equals pi times radius squared. 2. What formula is used to find the area of a rectangle? Area equals length times width. 3. What formula is used to find the area of a triangle? Area equals 1/2 base times height. 4. What formula is used to find the volume of a cylinder? Volume equals pi divided by 4 times diameter squared times height. 5. What formula is used to find the volume of a rectangular solid? Volume equals length times width times height. 6. What is meant by the root of a number? The root of a number is one of two or more equal numbers that when multiplied together will produce the number. 7. What is an angle? A figure formed by two lines radiating from a common point. 8. What is meant by a right angle? An angle of 90 degrees. 9. What is an obtuse angle? An angle greater than 90 degrees but less than a straight line. 10. What is an acute angle? An angle between 0 degrees and 90 degrees. What is a quadrant? 1/4 of a circle. 12. What is a sector? The portion of a circle bounded by two radii and one of the intercepted arcs. 13. What is a polygon? A closed figure having three or more sides. 14. What is an acute triangle? A triangle with three acute angles. 15. What is an obtuse triangle? A triangle with one obtuse angle. 16. What is a right triangle? A triangle containing 90-degree angle. 17. What is an equilateral triangle? A triangle with three equal sides. 18. What is an isosceles triangle? A triangle with two equal sides. 19. What is a scalene triangle? A triangle in which no two sides are equal. 20. What is the hypotenuse of a right triangle? The side opposite the right angle. 21. What is a quadrilateral? A polygon having four sides. 22. What is a parallelogram? A closed four-sided figure in which the opposite sides are parallel. 23. What is a trapezoid? A closed four-sided figure in which only one pair of opposite sides are parallel. 24. What is a hexagon? A closed figure with 6 equal sides. 25. What is the significance of the constant pi? Pi is the constant amount of the circumference of a circle is greater than its diameter. 26. What is the value of the constant pi? Pi equals 3.1416. 27. What is meant by a ratio and how is a ratio expressed? A fraction that compares one number to another. For example, 6:2 is a ratio. 28. What is meant by a proportion? A statement of equality between two ratios. For example, A divided by B equals B divided by C is a proportion. 29. What is meant by a percentage? A fraction having 100 as a denominator. For example, 65% equals 65 over 100. 30. What is the square root of 4096? 64. 31. What is the square of 99? 9801. 32. What is the cube of 5? 125. 33. What is the cube root of 1000? 10. 34. What is 50 gallons converted to liters? 189.3 liters. 35. What is 25 kilos converted to pounds? 55 pounds. 36. What is the base in the following expression? 10 to the power of 3. 10. 37. What is the exponent in the following expression? 10 to the power of 3. 3. 38. What is meant by scientific notation? A method of writing very large or very small numbers using powers of 10. 39. How do you write 56 million in scientific notation? When converting standard notation to scientific notation, move the decimal to the left or right until there is one non-zero integer on its left. If you move the decimal to the left, you'll multiply by 10 times the number you moved it to the left. So 56 million would be 5.6 times 10 to the 7th power. 40. How do you write 0.000000096 in scientific notation? (9.6) times 10 to the negative 7th. 41. What is 57,435 rounded to the nearest hundred? 57,400. 42. What is 3.141592 rounded to the nearest thousandth decimal point? 3.142. 43. What is the 8th power of 2? 256. 44. What is the official system of measurement used throughout the world, especially in scientific notation? The metric system. 45. What is meant by a negative number? A number less than 0 or a number preceded by a minus, parentheses negative sign. 46. What steps are used to add signed numbers? 1. Add all numbers having a plus sign. 2. Add all numbers having a minus sign. 3. Of these numbers, subtract the smaller from the larger number. The sign of the answer will be the sign of the larger number. 47. What steps are used to subtract signed numbers? 1. Change the sign of the subtract hand, parentheses the number that is being subtracted. 2. If the signs are alike, add the two numbers and attach the common sign. 3. If the signs are different, subtract the smaller from the larger and give the answer the sign of the larger. 48. What steps are used to multiply signed numbers? 1. Multiply the numbers disregarding the signs. 2. If the signs of the two numbers are alike, the sign of the answer is positive. 3. If the signs of the two numbers are not alike, the sign of the answer is negative. 49. What steps are used to divide signed numbers? 1. Disregard the signs and divide as though the numbers had no signs. 2. If the signs of the two numbers are alike, the sign of the answer is positive. 3. If the signs of the two numbers are not alike, the sign of the answer is negative. 50. What is the precedence of operations when solving an algebraic equation? 1. Grouped expressions such as parentheses and radial expressions, parentheses square roots. 2. Exponents. 3. Multiplication and division. 4. Addition and subtraction. 1. What is the sum of positive 6 plus positive 12? 18. 52. What is the sum of positive 6 plus negative 12? Negative 6. 53. What is the difference between positive 6 minus positive 12? Negative 6. 54. What is the difference between negative 6 minus positive 12? Negative 18. 55. What is the difference between negative 6 minus negative 12? 6. 56. What is the product of negative 6 times negative 12? 72. 57. What is the product of negative 6 times positive 12? Negative 72. 58. What is the quotient of negative 6 divided by positive 12? Negative 1/2. 59. What is the quotient of negative 6 divided by negative 12? 1/2. Note we are now in the risk management section. Question 1. What are the risks associated with incorrectly applying the precedence of operations when solving algebraic equations? Incorrectly solving algebraic equations can have serious consequences. One example is incorrectly computing the center of gravity, CG, after weighing an aircraft. An incorrectly computed CG could lead to a catastrophic outcome if the aircraft is loaded outside of the actual allowable limits. 2. What are the dangers of incorrectly applying the rules of adding and subtracting positive and negative integers? When installing and removing equipment from an airplane, it is important that the calculations are correct. Components may be either ahead or behind the datum, and thus the moments can be either positive or negative. Incorrectly applying the rules of positive and negative integers will cause the stated weight and balance of the aircraft to be incorrect. 3. What are the dangers of incorrectly rounding off calculations? Rounding off calculations too far or incorrectly can lead to many dangerous situations. This can result in replacement of wires that are too small, switches and circuit breakers that are not rated sufficiently for the load of the circuit, incorrectly sized alternators, and many other dangerous situations. Regulation, maintenance, forms and records, and publications. 1. Who is authorized to perform a 100-hour inspection on an aircraft? A certificated aviation mechanic who holds an airframe and power plant rating. 2. Who is authorized to perform an annual inspection on an aircraft? A certificated A&P mechanic who holds an inspection authorization. 3. Can a certificated A&P mechanic supervise an unlicensed person as the unlicensed person performs a 100-hour inspection on an aircraft? No, a certificated mechanic must personally perform the inspection. 4. Who is authorized to rebuild an aircraft engine and issue a zero-time maintenance record? Only the manufacturer of the engine or a facility approved by the manufacturer. 5. Which FAR specifies required maintenance records? 14 CFR Section 91.417 specifies you must keep records of maintenance, preventive maintenance, major repairs and alterations, and 100-hour annual and progressive inspections. 6. Are instructions included in the federal regulations mandatory or optional? They are mandatory. 7. Who is authorized to approve an aircraft for return to service after a major repair? An aircraft mechanic holding an inspection authorization. 8. Who is authorized to perform preventative maintenance on an aircraft that is not flown under Part 121, 127, 129, or 135? The holder of a pilot certificate that flies that particular aircraft. 9. Who is authorized to rebuild an aircraft engine and issue a zero-time record? The manufacturer of the engine or a facility approved by the manufacturer. 10. Who is authorized to approve an aircraft for return to service after a minor alteration has been performed on the airframe? A certificated aviation mechanic holding an airframe rating. 11. What is the minimum age for an aviation mechanic certificate? 18 years. 12. What are the two ratings that can be issued to an aviation mechanic certificate? Airframe and power plant. 13. How many months of practical experience is needed to qualify for the aviation mechanic certificate with both airframe and power plant ratings? 30 months. 14. What can be used in place of the 30 months of experience to qualify to take the mechanics test? A certificate of completion from a certificated aviation maintenance technician school. 15. What type of experience is required to take the test for aviation mechanic certification? Practical experience with the procedures, practices, materials, tools, machine tools, and equipment generally used in constructing, maintaining, or altering airframes or power plant appropriate to the rating style. 15. What tests are used to demonstrate that a mechanic applicant has the proper knowledge? The written knowledge tests. 17. What tests are used to demonstrate that a mechanic applicant meets the minimum skill requirements? The oral and practical tests. 18. What certificate and ratings are required for a mechanic to conduct a 100-hour inspection and approve the aircraft for return to service? An aviation mechanic certificate with both airframe and power plant ratings. 19. What certificate and ratings are required for a mechanic to conduct an annual inspection and approve the aircraft for return to service? An aviation mechanic certificate with an inspection authorization. 20. When after making a permanent change of address, is the holder of an aviation mechanic certificate required to notify the FAA? Within 30 days. 21. Is a certificated aviation mechanic with airframe and power plant ratings authorized to perform 100-hour and annual inspections? No. Only 100-hour inspections. Inspection authorization is required to perform an annual inspection. 22. A certificated aviation mechanic may not supervise the maintenance, preventative maintenance, or alterations of, or approve and return to service any aircraft or appliance or part thereof for which the mechanic is rated unless he or she has met what stipulation? The mechanic must have satisfactorily performed the work concerned at an earlier date. 3. Is it permissible for a mechanic with an airframe and power plant rating to replace the tachometer cable for a magnetic drag tachometer? Yes, this does not constitute a repair to an instrument. 24. Is a certificated aviation mechanic with an airframe and power plant rating allowed to zero the pointers on a fuel pressure gauge? No, a mechanic is not allowed to make any repairs or alterations to an aircraft instrument. 25. How many months of experience within a 24-month period must a mechanic have to exercise the privileges of his or her certificate? At least 6 months. 26. How can a mechanic re-establish maintenance currency once it's lost? By working under supervision for 6 months, or if the administrator has found that they are able to do the work. 27. What record must be made of the compliance of an airworthiness directive? An entry must be made in the aircraft maintenance record stating that the AD has been complied with. This entry must include the AD number and revision date, the date of compliance, the aircraft total time and service, the method of compliance, and whether or not this is a recurring AD. If it is a recurring AD, the time of the next compliance must be noted. (28) What minimum information must be contained in a maintenance record? All maintenance entries at a minimum must include a description of the work performed, references to data acceptable to the administrator, the date the work was completed, the name and certificate number of the person performing the work, and if different, the signature and certificate number of the person approving the aircraft for return to service. 29. What records must be made of a 100-hour inspection before the aircraft is approved for return to service? An entry must be made in the aircraft maintenance records that describes the type, the extent, and the date of inspection, the aircraft total time in service, and the signature, certificate type, and number of persons approving or disapproving the aircraft for return to service. 30. Where can you find an example of the correct type of write-up to use for recording a 100-hour inspection in the aircraft maintenance record? In 14 CFR Part 43, Section 11. 31. What action must the mechanic take if the aircraft he is inspecting on a 100-hour inspection fails because of an unairworthy component? The aircraft maintenance record must indicate that the aircraft has been inspected and found to be in an unairworthy condition because of certain discrepancies. A signed and dated list of these discrepancies must be given to the owner or lessee of the aircraft. 32. For how long must the record of a 100-hour inspection be kept? For 1 year or until the next 100-hour inspection is completed. 33. What record must be made of a major repair to an aircraft structure? An FAA Form 337 must be completed for the repair, and a record must be made in the aircraft maintenance records referencing the Form 337 by its date. 34. How many copies must be made of a Form 337 after a major airframe repair? What is the disposition of each copy? At least 2 copies must be made. The original signed form goes to the aircraft owner, and a copy goes to the FAA district office. 35. How long must major repair alteration records be kept? A copy of all Forms 337s must be kept for the life of the aircraft. 36. What is the malfunction in a defect report? Malfunction and defect reports (FAA Form 8010-4) are a voluntary reporting mechanism to report unusual problems or weaknesses not associated with expected wear. 37. Where can you find a list of basic items that must be inspected on a 100-hour inspection? In 14 CFR Part 43, Appendix D. 38. What is meant by progressive inspection? An inspection that is approved by the FAA FSDO in which an aircraft is inspected according to an approved schedule. This schedule allows the complete inspection to be conducted over a period of time without having to keep the aircraft out of service as long as would be necessary to perform the entire inspection at one time. 39. What is meant by permanent maintenance records? Permanent maintenance records are kept for the life of the aircraft and are transferred when a change in ownership occurs. Permanent records include total time and service of the airframe, engines, propellers, and rotors, the status of life-limited parts, time since overhaul on items with specified time limits, current inspection status, current AD status, including AD numbers, revision dates, recurrence dates, and methods of compliance, and copies of any Form 337. 40. What is the purpose of 14 CFR Part 43? It describes maintenance, preventive maintenance, rebuilding, and alteration of certificated aircraft. 41. What is preventive maintenance? Who may perform preventative maintenance, and what maintenance record entries are required? Preventative maintenance is limited to the list of items given in 14 CFR Part 43, Appendix A, and may not include any complex assemblies. A person holding at least a private pilot certificate may approve the aircraft for return to service and must make an entry in the aircraft maintenance records. 42. What determines if an alteration or repair is considered major? The lists of the types of repairs and alterations that are considered majors are listed in 14 CFR Part 43, Appendix A. 43. What determines if an alteration or repair is considered minor? It is considered minor if it is not listed in 14 CFR Part 43, Appendix A as a major repair or alteration. 44. What is done with the aircraft maintenance records that include the current status of the applicable airworthiness directives when the aircraft is sold? These maintenance records must be transferred with the aircraft when it is sold. 45. What is a type certificate data sheet? The TCDS is a formal description of the aircraft engine or propeller. It lists limitation and information required for type certification, including airspeed limits, weight limits, thrust limitations, and so forth. 46. What are aircraft specifications? Documents that include basically the same information as the TCDS but are issued for aircraft engines, propellers, certificated under the Air Commerce Regulations. 47. What document specifies the type of fuel that should be used in an airplane? The TCDS for that airplane. 48. What document would you use to find the control surface movement for a specified airplane? The TCDS for that airplane. 49. Why is it necessary to refer to the TCDS for an airplane when conducting a 100-hour inspection? The TCDS includes the specifications required for the aircraft to maintain its airworthiness status. 50. What FAA publication describes methods of non-destructive testing? AC 43-3, non-destructive testing in aircraft. 51. What is the purpose of an AD? It provides guidance and information to owners and operators of aircraft, informing them of the discovery of a condition that prevents the aircraft from continuing to meet its condition for airworthiness. 52. What is the first step in issuance of an AD? A Notice of Proposed Rulemaking (NPRM) is published in the Federal Register. 53. How is information on an AD disseminated? It is printed and distributed by first-class mail to the registered owners and certain known operators of the products affected. 54. What type of AD may be adopted without an NPRM? ADs of an urgent nature are issued as immediately adopted rules without prior notice. 55. How is information on emergency ADs sent to the owner or operator of an affected aircraft or other product? By first-class mail, telegram, or other electronic method. 56. Where can you find a list of all of the ADs that apply to aircraft, engines, propellers, or appliances? On the FAA's website under the Dynamic Regulatory Systems, (DRS). 57. How can you get information on subscribing to the airworthiness directives? Contact FAA, Manufacturing Standards Section, AFS-613, P.O. Box 26460, Oklahoma City, OK 73125-0460. 58. What is the significance of the identification number 91-08-07R1? (91) stands for an AD that was issued in 1991. (08) This AD was issued in the 8th biweekly period, (15th or 16th week) of 1991. (07) This is the 7th AD issued during this period. R1 stands for the first revision of this AD. 59. Is it mandatory that the information in an AC be complied with? No, this information is advisory in nature. 60. With which part of 14 CFR is AC 43.13-1B associated with? (14 CFR Part 43). 61. May all of the information in AC 43.13-1B be used as approved data? No. It is acceptable but not necessarily approved data. 62. What is the purpose of general aviation airworthiness alerts? They contain information gleaned from malfunction and defect reports to warn maintenance personnel of problems that have been reported. 63. If an individual develops a different process for complying with an AD, are they allowed to use that process? They are not allowed to deviate from the AD unless they submit the process to the administrator as an alternative method of compliance, parentheses AMOC, and the AMOC is approved. 64. Who issues a service bulletin and what is its purpose? It is issued by the manufacturer and used to outline procedures to make the product operate more efficiently and/or safer. 65. May the data in an aircraft maintenance manual be used as approved data for an aircraft repair? No. An aircraft maintenance manual contains repair data acceptable to the FAA for minor repairs only. If approved data is needed for a major repair, consult the aircraft manufacturer's FAA-approved structural repair manual, an FAA DER (designated engineering representative), or in some cases, AC 43.13-1. 66. Where would you find the dimensional tolerances for the wrist pin fit in an aircraft engine? In the overall manual for that engine. 67. What document would you use to find an approved repair for a damaged wing spar? The structural repair manual for the aircraft. 68. What document would you use to find the part number for a landing light bulb for an airplane? The Illustrated Parts Catalog. 69. What document would you use to troubleshoot a malfunctioning electrical flap system? The Aircraft Wiring Diagram Manual. 70. Where would you find the empty weight of an airplane? In the aircraft weight and balance records. 71. What is the purpose of a minimum equipment list, (MEL)? An MEL permits operation with certain inoperative items of equipment for the minimum period of time necessary until repair or replacement can be accomplished. 72. What is a master minimum equipment list, (MMEL)? A document approved by the FAA that lists the minimum operative instruments and equipment required for safe flight in that aircraft type in each authorized operating environment. 73. Where are the FAA databases that include advisory circulars, ADs, TCDSs, and supplemental type certificates, (STCS)? On the FAA Dynamic Regulatory Systems (DRS) website. 74. Where does an aircraft manufacturer specify the compliance requirements for method, techniques, and practices? In the maintenance manual and instructions for continued airworthiness. 75. Where does an aircraft manufacturer specify maintenance and inspection intervals? in the maintenance manual and instructions for continued airworthiness. 76. Where does an aircraft mechanic find FAA-approved maintenance data, including maintenance manuals and other methods, techniques, and practices acceptable to the administrator? In the aircraft manufacturer's maintenance manual and instructions for continued airworthiness, and in advisory circulars, parentheses including AC 43.13-1 and AC 43.13-2. 77. What are the differences between approved data and acceptable data? FAA-approved data is required for major repairs and alterations, and acceptable data is required for minor repair and alterations. 78. What are instructions for continued airworthiness? FAA Order 8110.54A, Appendix I, defines instructions for continued airworthiness, parentheses ICA, as documentation that gives instructions and requirements for maintenance that is essential to the continued airworthiness of an aircraft engine or propeller, including appliances, components, or modifications. 79. What is an airplane flight manual, parentheses AFM, or pilot's operating handbook, parentheses POH? Required documents that must be carried in an aircraft that detail the operating limitations specific to that aircraft and its engines. 80. Where are the definitions found for warnings, cautions, and notes that are used in maintenance and operating manuals? The definitions for these words are found at the beginning of the manuals that they are used in, usually in Chapter 1. 81. What FAA regulation provides guidance for the use of placards when operating with inoperative equipment? (14 CFR Part 91.213). 82. How are parts identified in a manufacturer's parts manual to specify the specific serial number of aircraft that the part is valid for? Through the use of usable on or effectivity codes. 83. Where are the parts numbers found for a specific aircraft model and serial number? In the manufacturer's parts manual or illustrated parts catalog, parentheses IPC. 84. How soon after a change in permanent mailing address should a mechanic notify the FAA? Within 30 days. 85. What is the method of notifying the FAA of a change of address? Either through the mail with the FAA's office in Oklahoma City or online through the FAA Airman Services. Note we are now in the risk management section. Question 1. Why is it important for maintenance documentation to be accurate or complete? Incomplete or inaccurate aircraft records leads to incorrect maintenance history and understanding of the status of the aircraft, which can cause unairworthiness and possible unsafe condition. 2. Why is it important to use SDS, parentheses, safety data sheets? To promote safe working conditions for personnel and prevent damage to aircraft components caused by improper use of materials and chemicals. 3. Explain the dangers of competency during documentation phase of maintenance and procedures. Competency during the documentation phase can cause incomplete records and uncertainty of aircraft and component status. 4. Why is it important to follow warnings, cautions, and notes in maintenance and operational manuals? Failure to follow warnings, cautions, and notes can lead to unsafe conditions and damage to the aircraft components, and other aircraft, and injury to personnel. 5. Describe how to determine if a part applies to a given aircraft. When looking up a part in the Aircraft's Illustrated Parts Catalog, IPC, it is important to understand aircraft configuration as listed in the Aircraft Type Certificate Datasheet (TCDS), and to know the specific serial number of the aircraft. In addition, the aircraft records should be checked and approved for modifications or repairs as shown in AD records and in Supplemental Type Certificates (STC) in the aircraft maintenance records. Physics for aviation. 1. What is meant by matter? Anything that occupies space and has weight. 2. What are 3 basic physical states in which matter can exist? Solid, liquid, and gas. 3. What is meant by energy? The capacity for doing work. 4. What formula is used to find the amount of work done when an object is moved across a floor? Work equals force times distance. 5. What determines the mechanical advantage of an arrangement of ropes and pulleys? The number of ropes that support the weight. 6. What determines the mechanical advantage of a gear train? The ratio between the number of teeth on the drive gear and the number of teeth on the driven gear. 7. What is meant by the fulcrum of a lever? The point about which the lever rotates. 8. What are examples of a first-class lever, a second-class lever, and a third-class lever? A screwdriver being used to pry the lid from a can of paint is an example of a first-class lever. A wheelbarrow is an example of a second-class lever. A hydraulically retracted landing gear is an example of a third-class lever. 9. What is meant by pressure? Force that acts on a unit of area. 10. What is the standard sea level atmospheric pressure expressed in inches of mercury and in pounds per square inch? (29.92 inches of mercury and 14.69 pounds per square inch). 11. What characteristic of the atmosphere determines the speed of sound? Its temperature. 12. What is meant by a temperature of absolute zero? The temperature at which all molecular movement stops. 13. What is the Celsius equivalent of a temperature of 50 degrees Fahrenheit? 10 degrees Celsius. 14. What are 3 methods of heat transfer? conduction, convection, and radiation. 15. What is meant by the absolute humidity of the atmosphere? The actual amount of water that is in a given volume of air. 16. What causes ice to change into liquid water? The absorption of heat energy. 17. What happens inside a solid material when it absorbs heat energy? The molecules within the material move faster. 18. What is the basic unit of heat in the English system? British thermal unit. 19. How much work will 1 BTU of heat energy perform? 778 foot-pounds of work. 20. What is the basic unit of heat in the metric system? Calorie. 21. How much heat energy is in a small calorie? The amount of heat energy that will rise the temperature of 1 gram of water 1 degree Celsius. 22. How much heat energy is in a large calorie? The amount of heat energy that will rise the temperature of 1 kilogram of water 1 degree Celsius. 23. What is the first law of thermodynamics? Heat energy can neither be created nor destroyed, it can only be changed in its form. 24. What is the second law of thermodynamics? Heat energy can only flow from a body having a high temperature to a body having a low temperature. 25. What is an example of heat transfer by conduction? Removal of heat from an engine cylinder by air flowing over its surface. 26. What is an example of heat transfer by convection? The uniform heating of the air in a room by a floor heater. The heated air rises and forces the colder air down so it can be heated by conduction. 27. What is an example of heat transfer by radiation? The heating of Earth's surface by heat transmitted through the space from the sun. 28. Why do most metals expand when they are heated? As heat is absorbed, the electrons move faster and expand their orbits in the molecules of the metal. 29. What is Bernoulli's principle? Bernoulli's principle states that an increase in speed of a fluid results in a decrease in pressure of the same fluid. 30. What is Newton's first law of motion? Newton's first law of motion states that a body at rest remains at rest and a body in motion will continue in a straight line unless acted on by a force. 31. What are two types of fluids? Liquids and gases. 32. What is meant by the density of a fluid? The mass per unit volume of the fluid. 33. What is meant by the specific gravity of a fluid? The ratio of the density of the fluid to the density of pure water. 34. What effect does the increase in temperature of a confined gas have on its pressure? When the volume of a gas remains constant, an increase in its temperature increases its pressure. 35. What effect does high humidity have on piston engine performance? Water vapor is less dense than dry air, and thus high humidity decreases the density of the air. The less dense air decreases engine performance. 36. How many cubic inches of fluid is forced out of a cylinder by a piston with an area of 20 square inches when the piston moves 5 inches? 100 cubic inches. 37. What will happen to the pressure of a confined gas if the temperature of the gas is increased? The pressure will increase. 38. What is meant by the density of air? The weight of a given volume of air. 39. What is meant by relative wind with regard to an airfoil? The direction the wind strikes an airfoil. 40. What is meant by the mean aerodynamic chord, parentheses Mach? Mach is the average distance from the leading edge to the trailing edge of the wing. 41. What is meant by the angle of attack? The acute angle formed between the chord line of an airfoil and the direction the air strikes the airfoil. 42. What is meant by the critical angle of attack? The highest angle of attack at which the air passes over the airfoil in a smooth flow. Above the critical angle of the attack, the airfoil breaks away and becomes turbulent. 43. What is meant by the stagnation point of an airfoil? The point on the leading edge of an airfoil at which the airfoil separates some flowing over the top and some over the bottom. 44. What is the difference between speed and velocity? Speed is the rate at which an object is moving. Velocity is the vector quantity that expresses both the rate and direction of an object is moving. 45. What is meant by air density? The mass of air in a given volume. 46. What is meant by weight? The measure of the force of gravity acting on a body. 47. What is meant by thrust? The forward aerodynamic force produced by a propeller, fan, or turbojet engine as it forces a mass of air to the rear behind the plane. 48. What is meant by drag? The aerodynamic force acting in the same plane as the relative wind striking an airfoil. Drag acts in the direction opposite to that of thrust. 49. What is meant by autorotation in a helicopter? The aerodynamic force that causes a helicopter rotor to spin with no engine power applied to the rotor system. 50. What is meant by dissymmetry of lift produced by a helicopter rotor? The difference in lift between the two sides of the rotor discs when the helicopter is in forward flight. The side with the advancing blade produces the greater lift because the forward speed adds to the rotor speed. The side with the retreating blade produces less lift because the forward speed subtracts from the rotor speed. 51. What is meant by blade stall of a helicopter rotor? A condition of flight in which the retreating blade is operating at an angle of attack higher than will allow for the air to flow over its upper surface without turbulence. 52. What is meant by translational lift in a helicopter? The additional lift produced by a helicopter rotor as the helicopter changes from hovering to forward flight. (53) What is meant by ground effect in a helicopter flight? An increase in lift when a helicopter is flying at an altitude of less than half the rotor span. This increase is produced by the effective increase in the angle of attack caused by the deflection of the downwashed air. 54. What is meant by ground resonance in a helicopter? The destructive vibration that occurs when the helicopter touches down roughly and unevenly. The shock throws a load into the lead lag hinges of the rotor blades and causes them to oscillate about this hinge. If the frequency of this oscillation is the same as the resonant frequency of the fuselage, the energy will cause the helicopter to strike the ground hard with the opposite skid or wheel. If corrective action is not taken immediately, ground resonance can destroy the helicopter. 55. What effect does an increase in density altitude have on engine performance? As density altitude increases, air density decreases and engine performance decreases. 56. How do flaps allow an airplane to take off and land at a slow airspeed? The extension of flaps increase the camber of the airfoil, causing greater lift and drag. 57. Why do slots and slats delay the onset of a stall to a higher angle of attack? They allow the airfoil to remain attached to the upper surface of the wing at higher angles of attack, reducing stall speeds. 58. What is the purpose of stall strips on the leading edge of an airplane wing? Stall strips cause a disruption to the airflow as an angle of attack increases, causing the inboard section of the wing to stall before the outboard wing. 59. What is the function of wing fences on an aircraft? Wing fences or stall fences delay the stall from reaching the airlines, allowing improved aileron control at slower airspeeds. 60. How do vortex generators prevent the onset of airflow separation at high angles of attack? Vortex generators create a small vortex or disturbance that causes the air to remain attached to the surface at higher angles of attack. 61. What is the relationship between temperature, density, weight, and volume? As temperature increases, density decreases and volume increases. As density decreases, the weight of a set volume also decreases. 62. What effect does an increase in the volume of a gas have on its temperature if its pressures remain constant? As the volume of a gas increases with a constant pressure, the temperature decreases. 63. What effect does an increase in the pressure of a confined gas have on its temperature? Increasing the pressure of a confined gas increases its temperature. 64. What is the difference in the fluids used in hydraulic systems and those used in pneumatic systems? Fluid used in a hydraulic system is incompressible. Fluid used in a pneumatic system is compressible. 65. What effect on density altitude is caused by an increase in air temperature? As the temperature increases, the air density decreases and the density altitude increases. 66. What is meant by the resonant frequency of an aircraft structure? The frequency that produces the greatest amplitude of vibration in the structure. 67. How much force is produced by 1000 psi of hydraulic pressure acting on a piston with an area of 20 square inches? 20,000 pounds. Note we are now in the risk management section. Question 1. What risks are associated with aircraft operations at higher density altitudes? As density altitude increases, engine performance decreases and aircraft aerodynamic performance decreases. 2. Explain the potential risks associated with a repair to a control surface. An incorrectly repaired control surface can begin to flutter during flight and separate from the aircraft. 3. What are the risks of an individual creating their own performance and testing data? Performance and testing data are used by aircraft manufacturers to show that their products meet the regulations that they are being certified to. Their certification criteria can be complex and specific to certain aircraft components. It is dangerous for a certified mechanic or pilot to develop their own testing of a modification without consulting the FAA Aircraft Certification Office in their district. 4. Describes the risks associated with confusing Celsius versus Fahrenheit, gallons versus liters, or pounds versus kilogram. Confusing English and metric units of measure can lead to misreading of performance charts, fueling an aircraft with less fuel than necessary, overloading an aircraft beyond maximum allowed weight, and many other dangers. Inspection concepts and techniques. 1. What are different types of micrometer calipers? Outside micrometer, inside micrometer, depth micrometer, and thread micrometer. 2. How often should torque wrenches be calibrated? Depending on the tool, some are calibrated every 6 months, while others are calibrated every 12 months. 3. What is the proper type of non-destructive inspection to use for locating surface cracks in an aluminum alloy casting or forging? Fluorescent or visual dye penetrate. 4. What is the principle upon which ultrasonic inspection is based? Any fault within a material will change the material's resonant frequency. Comparing the resonant frequency of a known sound material with the material under the test will indicate the presence of a fault. 5. What is the procedure when making a dye penetrant inspection of a part? Clean the part thoroughly, apply the penetrant, and allow it to soak for the recommended dwell time. Remove all of the penetrant from the surface and apply the developer. 6. In addition to 100-hour and annual inspections, where would an aircraft operator find the approved inspection programs for an aircraft? In the Aircraft Manufacturer's Maintenance Manual and Instructions for Continued Airworthiness, ICA. 7. What inspection method would be most appropriate for checking a non-ferrous metal part for intergranular corrosion? Eddy current inspection. 8. What inspection method would be most appropriate for checking the internal structure of an airplane wing for corrosion? X-ray inspection. 9. What inspection method would be most appropriate for checking a steel landing gear component for stress cracks? Magnetic particle inspection. 10. What type of inspection is best suited for detecting a fault within a piece of non-ferrous metal? Ultrasonic inspection. 11. Why is it important that all parts be thoroughly cleaned before they are inspected by the dye penetrant method? Any grease or dirt in a fault will keep the penetrant from seeping into the fault. 12. What is the procedure to use when performing a magnetic particle inspection of a part? Thoroughly clean the part, magnetize it as directed by the appropriate service manual, flow the indicating medium over the surface, and inspect it under a black light. When the inspection is complete, thoroughly demagnetize the part. 13. Why is it necessary to magnetize a part both circularly and longitudinally when inspecting a steel part by the magnetic particle method? To detect faults that extend across as well as lengthwise within the part. 14. Does circular magnetism detect faults that are across or lengthwise to the part? Lengthwise. 15. Why is it important that all engine parts that have been inspected by the magnetic particle method be completely demagnetized? If the parts are not completely demagnetized, they will attract steel particles that are produced by engine wear and will cause damage to bearing surfaces. 16. What is the principle of eddy current inspection? A current that is induced into the metal being tested by a test probe. The amount of induced current is determined by the conductivity, mass, and permeability of the material and the presence of any fault or void. Note we are in the risk management section. Question 1. Why is it important to demagnetize a component following a magnetic particle inspection? To prevent magnetized parts from attracting filings, grindings, chips, or other steel particles which can cause scoring, damage, and premature wear. 2. What are the dangers of the incorrect use of precision micrometers and calipers? Incorrect measurement of close tolerance components can lead to failure of critical parts and assemblies. 3. Why is calibration of precision measuring equipment important? Measuring equipment that is out of calibration can result in incorrect measurements, which can lead to component and system failure. 4. What are the risks of not using the correct inspection techniques? Incorrect inspection techniques will lead to the aircraft or component not being inspected in accordance with the manufacturer's specifications, which can lead to failure of the inspected item. 5. What precautions should be taken when using a multimeter to measure resistance, voltage, and current? Incorrect use of a multimeter can cause damage to the multimeter and/or result in incorrect conclusions regarding the circuit or component being tested. When used as an ohm meter, the component being measured must be isolated (disconnected) from the circuit. If the multimeter is set for measuring current and the leads are placed across any voltage drop, the meter can be damaged. A thorough understanding of the circuit being tested is critical for proper troubleshooting. Human factors. 1. How would you describe an organization that has a positive safety culture? An organization that has a set of shared beliefs and attitudes that promote safety through communication, training, and other actions within all levels of the workforce. 2. What are the 4 areas that are assessed in an organization when evaluating human factors relating to safety? The PAIR model describes these areas as people (the workforce), the environment where people work, the actions people take, and the resources that are available. 3. What is a safety management system (SMS) in an organization? An SMS is a systematic approach to providing acceptable levels of safety risk within the organization. This approach ties together safety policies, risk management, safety assurance, and safety promotion. 4. What are the different types of human error? Human errors can be grouped omission, commission, and extraneous errors. Omission errors are tasks which should have been performed but were not. Commission errors are tasks which were done incorrectly. Extraneous errors occur when an individual performs a task that was not authorized. 5. What is the difference between an active error and a latent error? An active error is an error that is committed by the person doing the work. A latent error is the one that comes from the administrative decision, a flaw in the system, or a culture that exists in a workplace. Latent errors may take a long time to be seen and usually show up as an active error that has roots in the latent error. 6. What are the different levels of consequences of human error? Little or no effect, damage to equipment or hardware. The equipment or hardware can be replaced but at a loss of time and financial setback. Personal injury, injury to an aviation mechanic, aircraft operator, or passenger. Catastrophic damage, parentheses, loss of life or loss of an aircraft. 7. How can the meta model be used for evaluating incidents or accidents caused by an aviation mechanic or inspector? The meta model is used to identify contributing factors behind the error. Meta stands for Maintenance Error / Event Decision Aid Model. The contributing factors are analyzed to determine the probability that will cause an error, and then the error is analyzed to determine the probability that the error will cause an event. 8. What is the shell model for event investigation? The shell model stands for Software / Procedures. Software is referring to the intangible part of the system, such as rules, regulation, customs, habits, and the procedures involved. Hardware. Hardware represents the physical aspects that the aviation mechanic works with, including the aircraft tools, hardware, and facilities. Environment. The physical environment in which the work is being done. Liveware / personnel. Liveware is the human element in the system. All 4 aspects overlap to some extent, especially the human element. Each element is examined for interactions with the other element when investigating the issue. 9. How can human limitations affect an individual's performance? People is the P in the pair model and describes how people who do the work are the center of all work. There are many factors that can affect or limit an individual's ability to perform work. Some of these limitations can include physical size, age, strength, sensory limitation. Psychological, including nutritional factors, health, lifestyle, fatigue, chemical dependency. Psychological, including workload, experience, knowledge, training, attitude, mental or emotional state. And psychosocial, interpersonal conflicts. 10. What elements of the physical environment can affect an aviation mechanic's ability to perform work? An aviation mechanic ability to perform work safely can be affected by weather, parentheses, hot, cold, rain, lightning, wind. Location, parentheses, protection from the elements. Workspace, parentheses, having enough room to adequately perform the work. Shift, parentheses, late nights or being too tired can affect an individual's capacity to think clearly and reduce manual and cognitive skills. Lighting, parentheses, the environment can be too dark or too bright to effectively see and perform work. Sound level, parentheses, an environment that is too loud can cause injury to hearing and disrupts the work at hand. Safety, parentheses, safety can be compromised by working at heights moving equipment, hazardous materials, or any number of conditions within a work environment. 11. How can organizational social environments affect an aviation's mechanic ability to effectively perform work? The culture within which an individual works can have a large impact on their ability to work safely and effectively. Areas that impact an organization's environment are personnel, supervision, labor management relations, pressures, crew structures, size of company, profitability, morale, corporate culture. 12. How does the reporting of hazards within an organization tie into the overall safety policy? Management of an organization defines and controls the safety policy as they are the ones who are ultimately responsible for safety within the organization. There must be clear goals that are openly communicated regarding the reporting of hazards for safety goals to be met. 13. Why is good communication important in an aviation work environment? Individuals having differing ways of expressing and receiving ideas, opinions, and instructions. If a team of aviation mechanics is going to work together on a large project, it is vital that they understand each other and can perform the work safely and efficiently. In addition to communicating clearly with each other, they must also be able to communicate clearly with supervisors, the aircraft owner, and the suppliers of aircraft parts and services. 14. What is a reactive approach to hazard identification? The reactive approach to hazard identification investigates accidents, incidents, and events. The investigation occurs after the occurrence. 15. What is a proactive approach to hazard identification? The proactive approach to hazard identification actively identifies safety hazards through analysis of the organization's activities through mandatory and voluntary reporting system, safety audits, and safety surveys. 16. What is a predictive approach to hazard identification? The predictive approach to hazard identification captures system performances as it happens during normal operation, such as observing mechanics' performance during a heavy check. 17. What are the elements of good teamwork? Most aviation mechanics work as a part of a team to do their work. The team must function cohesively to accomplish the work at hand safely and correctly. This includes good communication, understanding the end goal, watching out for teammates, and cooperating with each other. Part of the team attitude is understanding that your actions and attitudes directly affect those around you. 18. How does leadership affect the safety culture in an organization? For a safety management system to be effective, senior management must lead by example and promote safety culture through policies, promotion, and risk management. If the leaders of a company are not completely supportive of a safety culture, it will show through and will become less important to the rest of the company. 19. How can communication affect and facilitate teamwork? Communication is key for individuals to work together as a team. Discuss specific duties when job requires more than one person to eliminate missing steps or tasks. When assigning work to an individual, never assume that they have all the information and resources needed for the task. Verify their understanding of critical tasks by making sure they have access to the correct manuals and understand the process to be completed. 20. What does professionalism mean from the standpoint of an aviation mechanic? Professionalism is the conduct and practice of doing one job with skill, competence, ethics, and courtesy. A professional aviation mechanic will understand and carry out proper recommended maintenance procedures and will have the necessary skill to perform the task. The individual recognizes when their understanding of a task is lacking and will seek appropriate guidance. A professional will treat all other individuals with courtesy and respect, regardless of their position. 21. What does it mean for an aviation mechanic to work with integrity? To work with integrity means that the aviation mechanic will not compromise safety, airworthiness, regulations, or company policies, regardless of who sees, parentheses, or does not see what they do. 22. What does an aviation mechanic's signature on a document indicate? An aviation mechanic's signature is their word, indicating that each and every task was performed as required to the best of their ability. The signature is directly linked to the aviation mechanic's professionalism and integrity. To sign a document knowing that something has not been completed or is wrong means that the integrity has been compromised. Once compromised, it is very difficult to earn integrity back. 23. What are the procedures necessary for an effective shift change? Properly use logbooks and worksheets to communicate work accomplished and work to be done. At shift changes, maintenance personnel must discuss what work has been accomplished and what needs to be completed. Never assume work has been completed if there is no record of completion. In addition to a written record of work accomplished, there should be a verbal brief between shifts to provide further details and to allow for questions regarding the status of the work. 24. What should be included in a written transfer of a critical task? When transferring a critical task, it is important to record exactly what has been accomplished up to that point, as well as a critical task not yet completed. 25. How does our recognition of conditions or preconditions for unsafe acts affect safety? If aviation mechanics can recognize they are in the state which errors can occur, they can change the condition and prevent errors. 26. What is the danger of having two or more unsafe conditions present? When two or more factors are present, the error probability increases dramatically. 27. What are the dirty dozen of aviation maintenance? The dirty dozen is a list of 12 factors or conditions that could lead to an aviation mechanic making an error. The 12 factors are: 1. Lack of communication. 2. Competency. 3. Lack of knowledge. 4. Distraction. 5. Lack of teamwork. 6. Fatigue. 7. Lack of resources. 8. Pressure. 9. Lack of assertiveness. 10. Stress. 11. Lack of awareness. 12. Norms. 28. What is an error of omission? Omission errors are tasks which should have been performed but were not. Examples are missing a step in an inspection or not installing a washer or cotter pin. 29. What is an error of commission? Commission errors are tasks which were done incorrectly. This could be torquing a fastener to the wrong torque or timing a magneto to an engine at the wrong number of degrees. 30. What are extraneous errors? Extraneous errors occur when an individual performs a task that was not authorized. 31. What is the difference between a human error and a violation? A human error is an action performed by an individual that has unintended consequences. An action that is performed with full knowledge of what consequences are expected or possible is called a violation. Note, we are now in the risk management section. Question 1. Describe the effect of reporting only select hazards. The selective reporting of hazards means that some hazards will be overlooked and not reported. This can lead to risks in critical areas being overlooked and could eventually lead to an incident or accident. 2. How can the risks of selective reporting of hazards be mitigated? The hazard of selective reporting can be mitigated by emphasizing that all hazards be reported, no matter how insignificant they may seem. This discipline should be encouraged for all types of hazard identification, reactive, proactive, and predictive approaches. 3. What are some of the results of fatigue in an aviation mechanic? The results of fatigue include lack of judgment, inability to concentrate, decreased cognitive ability, reduced reflex time, and lack of coordination. 4. Are there other types of fatigue besides physical fatigue? Fatigues can be either physical or emotional. Emotional stress can be caused by a variety of factors from both within and from outside the workplace. 3. Describe the different parts of an effective fatigue risk management system, FRMS. An effective FRMS requires a systematic approach to safety reporting, integrated company policies, senior management commitment, incident reporting and analysis, continuous monitoring, and proactive risk assessment. 6. Is a safety management system, SMS, required to have a successful fatigue risk management system? No. A fatigue risk management system can be implemented as a part of an SMS or a standalone effort to reduce the risk associated with fatigue. 7. Describe some non-invasive tools that can be used to monitor and mitigate risk. A non-invasive tool is one that does not directly involve or interfere with an individual performing a task. Non-invasive tools include safety reporting, integrated company policies, senior management commitment, incident reporting and analysis, continuous monitoring, and proactive risk assessment. 8. What are some of the positive actions that an aviation mechanic can take to promote a safe and professional workplace? The Magnificent Seven attitudes were developed to help aviation mechanics focus on positive action and attitude. These are: 1. We work to accentuate the positive and eliminate the negative. 2. Safety is not a game because the price of losing is too high. 3. Just for today, zero error. 4. We all do our part to prevent Murphy from hitting the jackpot. 5. Our signatures are word and more precious than gold. 6. We are all part of the team. 7. We will always work with a safety net. That is the end of the FAA A&P General Study Guide questions. Thank you for taking the time to listen. I wish you luck, and remember, the answers don't have to be exactly phrased the way it was phrased in this seminar. Good luck, you got this. Please don't forget to subscribe and feel free to share, like, and comment. Feedback is appreciated. Thank you.